Problem solving with similar triangles. Three basic approaches to real-world problem solving include similar triangles, trigonometry, and the Pythagorean theorem. Shadows and similar triangles. One of the oldest math problems was solved using similar right triangles. About 2,600 years ago, Thales of Miletus, perhaps the first Greek mathematician, was visiting Egypt and wondered what the height of Cheops, one of the great pyramids of Giza, was. Due to the shape of the pyramid, he couldn't directly measure its height. When Thales visited the Great Pyramids 2,600 years ago, Cheops was already 2,000 years old. He wanted to know its height. He noticed that the pyramid cast a shadow, which could be measured on the ground using a measuring rod. And he realized that the vertical measuring rod also cast a shadow. Based on those two observations, can you think of a way that he could measure the height of the pyramid? What two properties do you recall about similar triangles? Their corresponding angles are congruent, and their corresponding sides are in proportion to one another. Draw a sketch of the pyramid being measured and its shadow. Then draw the measuring rod and its shadow. Represent the pyramid and rod as vertical lines, with the rod being much shorter than the pyramid. You won't be able to draw them to scale since the rod is so small compared to the pyramid, but that won't affect our thinking. Let's assume the sun's rays are parallel. Note that this drawing is not to scale. Here you can see the triangles. If we take away the objects and leave the triangles created by the height of the object, the sunlight, and the shadow on the ground, we can see that these are similar triangles. The angles are equal, so the sides are proportional. It's easy to see that they are similar when we put one triangle atop the other. Using the two ideas we came up with before, you know the angles are all the same and the sides are in proportion. Since the triangles are similar, the length of the shadow is in proportion to the height of its object. So here we have the height of the pyramid, the rays of sunlight, and the shadow of the pyramid. Here we have the height of the rod, the rays of sunlight, and the shadow of the rod. If the shadow of the rod is 2 meters long, the shadow of the pyramid is 120 meters long, and the height of the rod was 1 meter, then how tall is the pyramid? We just need to set up a ratio. So here we have the height of the pyramid over the pyramid's shadow equal to the height of the rod over the rod's shadow. So multiply both sides by the pyramid's shadow and then put in all of the values that we have, and we get that the pyramid is 60 meters high. This approach can be used to measure the height of a lot of objects which cast a shadow, and a convenient measuring device is then your height and the length of the shadow you cast. Try doing this on the next sunny day you can get outside. Measure the height of any object which is casting a shadow by comparing the length of its shadow to the length of your own. Reminder, mirrors also create indirect measurement if you are doing this lab on a cloudy day.